This is part 7 of rational expressions, and we're going to continue working with adding or subtracting rational expressions where we have a common denominator. Here's the first problem, and notice it's an addition problem, and the denominators are the same. So the rule is if you're adding fractions and you have a common denominator, you just write the denominator down for the new denominator, and then we add the numerators. So we have 9x minus 14 plus x squared minus 4x. By the way, you could put this on pause and do it on your own first. All right, next step. Well, look at that numerator. The next thing I would do is combine like terms. We've got a 9x and a minus 4x, but then notice it has an x squared term, so it seems reasonable to write this in descending order as far as the variables go. So let's do that. We'll first write the x squared, then we have the 9x and the minus 4x is plus 5x, and then we have minus 14. It's easier to factor if it's in descending order like that. Okay. So this is what we have so far by adding the two numerators. Now remember, you can't cancel at this point because it's not factored. You cannot cancel the x squares, you cannot cancel the 5 and the 10 or the x's, you cannot cancel the negative 14 or the 21, and if you want to help yourself remember that, just put a parentheses out around the numerator and around the whole denominator, and you can only cancel something in parentheses with something else that's exactly the same in parentheses. Okay, so we need to factor the numerator and the denominator. So let's do the numerator. Now you could do this on scratch paper, or you could do it by trial factors. This one isn't too difficult because they're both x's. And then we have a negative 14, so we're going to have factors of 14, and when I subtract them, I got to get 5. That'll be 7 and 2. I want to end up with a plus 5x, so it goes a plus 7 and a minus 2. And you should verify that by doing the FOIL method or any method. Make sure when you multiply it out, you would really get x squared plus 5x minus 14. Okay, now I'm going to give you a little hint. In the denominator, let's try doing this by trial factors. And if anything were to cancel, by the way, it would have to be an x plus 7 because of this last term being a 21. 2 isn't going to go into 21. So if this factors, there's not going to be an x minus 2, right? So let's just try x plus 7 times something. And if it was x plus 7, x times x will give you the x squared. 7 times what will give you 21? 3. And then make sure that really is the correct factorization. Well, the outer term is 3x, the inner term is 7x, and so that is the correct factorization. So sometimes if you look and see what the other factors are, that'll help you decide which trial factors to use. But it might not work out. In other words, it might not factor at all, or it might factor to something completely differently and nothing will cancel. But in this case, x plus 7 can be canceled. So my final answer is x minus 2 over x plus 3. And you have to know when you're done. Again, you cannot cancel those x's. Here's another problem, except this is a subtraction problem. So if you want, put it on pause and try it on your own. Okay, here we go. It's a subtraction problem with a fraction. You must have the common denominator in order to subtract, and you do, right? The denominators are the same. So what do? That's going to be the denominator still, x squared plus 10x plus 21. And then we have to subtract the numerators, but be careful. This is x squared plus 8x. You don't need to put that in parentheses, but the second one you do if you're going to write it with a minus sign and not do it in your head. So you're going to subtract that numerator 3x plus 14. So we have x squared plus 8x, and now we do the derivative property. Minus 3x minus 14, which is x squared plus 10x plus 21 still in the denominator. So the numerator, I get x squared plus 5x minus 14 over x squared plus 10x plus 21. Hey, does that look familiar to anybody? That's exactly what we had in the last problem. Check this out. Hey, that's exactly the same thing we got in the last problem. And so the steps from here will be exactly the same. We'll get an x minus 2 over x plus 3. So to finish this problem, you would factor the numerator and denominator and cancel the x plus 7's. Okay? So it will be exactly the same. You'll have x plus 7, x minus 2 over x plus 7, x plus 3. The x plus 7's will cancel, and you'll end up with x minus 2 over x plus 3. So it's just a variation on a theme. Here's the next example. X squared plus 3x minus 25 all over x squared minus x minus 20 minus 3x all over x squared minus x minus 20. So again, this is a subtraction problem, and the denominator is the same. So we can write the denominator. You only write it once. Make sure you don't try to add the denominators. It doesn't work, or subtract them. And then I take the numerator of the first fraction, x squared plus 3x minus 25, minus the numerator of the second. Now I could put a parentheses around it, but since there's only one term, I don't really need it. I just have minus 3x. Okay, so we need to simplify the numerator by combining like terms. So that'll give you x squared minus 25. And in the denominator, we've got x squared minus x minus 20. Remember, don't even think about canceling until things are factored. So from the very beginning, make sure you don't try to cancel the x squares, the x's, the 25 and the 20, none of that. Okay? So we get a common denominator, we add or subtract the numerators, and we're going to have to factor, if possible, to see if anything cancels. All right, so in the numerator, x squared minus 25, can you factor that? X plus 5 times x minus 5. So I'm wondering if one of those factors is a factor of the denominator. And it looks like either one might be, because 5 goes into 20 and they both have 5's. So let's see, I'll have to figure this out. Again, you could do this on scratch paper. So we've got x squared minus x minus 20. So we need factors of 20 for the last part here. And when I subtract them, I should get 1. So I think that's going to be a 5 and a 4. The question is which one's minus and which one's plus. And I'm going to have to get a minus 1x, so it's going to be a minus 5 and a plus 4. Now remember, you could write that as x plus 4 times x minus 5. Okay, now make sure that is the correct factorization. Do the FOIL method. And you do indeed get x squared minus x minus 20. So now if there's anything that can be canceled, you do cancel. And x minus 5 is the same. And therefore, we're left with an x plus 5 over an x plus 4. Now to be honest, in real life, it usually doesn't come out nice and tidy like this. Often, it doesn't factor at all, the numerator or denominator, or if they factor, nothing cancels. You can't be guaranteed, but you have to try to see if something cancels.